Alright everybody, welcome back to the workshop. Today we're going to be talking about Oxy Acetylene welding and cutting. And the first topic we're going to cover is setting your torch pressure. So for this, we're going to want to grab our Oxy Acetylene torch. It really doesn't matter what attachment you have on the top end, as long as these two valves at the bottom are closed at the moment. We can kind of start to unravel our hoses a little bit, and then we'll notice that we have two regulators here. We have a green regulator for oxygen, and we have a red regulator for our fuel gas. In this case, we're using acetylene. Now, on a torch system, on a tank system or a high pressure system, we need to be very careful with both of these because of how much pressure is coming into the lines, okay, and into the regulator. So with oxygen, we need to be very careful that we don't overload the regulator with pressure. So we need to turn it extremely slowly. For like a quarter of a turn, we want to point our head away from this regulator and this T-handle, or in this case we have a different adjuster. And we're going to want to turn it very, very slowly for about a quarter of a turn. Once we do that, we can open it all the way. On a manifold system like we have here, this is a low pressure system, so we don't have to be as cautious, but it's always just good practice to do it. And that way, if you're switching from a manifold system like here in the shop, or you're at work and you're using a high pressure system on tanks, that's you can apply the same technique for both and you'll never forget. Now for acetylene or our fuel gas, on a tank system or a high pressure system, generally speaking, you're gonna only turn it open about a quarter of a turn. But in this case, because we're on a manifold system, there's multiple lines working in one. We need to open the valve all the way so that everybody down the line can have full flow and full use of the regulator. So we can go ahead and turn that on all the way like this. Now, once we do that, now we can adjust pressures. Depending on what process we're doing, whether we're cutting, we're welding, we're cutting thick metal, we're welding thick metal, whatever the case is, we need to adjust the pressures of both oxygen and acetylene. For welding today, all we're going to adjust is, first I'll talk about fuel gas and then oxygen. You'll notice whenever we make an adjustment, we have to have the valve open for the gas that we're using. We need positive pressure flowing out, a continuous flow, for the regulator to accurately gauge and measure how much we're moving, okay? How much flow is going through. So if I turn on the fuel gas right here, now I can adjust. With a right hand turn, I can adjust my acetylene. I'm going to turn it up to 5. Once I've got it at 5, I'm going to turn it off. For welding specifically, we're going to use 5 for most applications. Now for welding with the oxygen, again, I'm going to turn this valve on and I'm going to adjust to 5 psi on the oxygen. It's a very small adjustment on the oxygen. The oxygen regulator has very large increments because when we're cutting, we need to use a lot more oxygen, and we'll talk about that as we move forward. So, thank you very much. This is how we can adjust our torch so we have a good working pressure on both our oxygen and acetylene for Oxy Acetylene welding and cutting. Thank you. Okay, so we have our acetylene open. You can hear the pressure going through it, and we're going to turn it up, right hand turn, until we get to 5. Then we can turn our acetylene off. Now we can turn our oxygen on. And again, you can see the increments go up very quickly. We just want to, that first increment is right at about 5. So right there, and boom, we're done. Now to shut off a system, what we want to do first is we want to close the valves here. Okay, so we'll start with acetylene. In any case of an emergency, we'll always shut acetylene off first because that's our fuel gas. But immediately then we want to shut off our oxygen. This is the same procedure regardless. Okay, now what we can do is we can open up our lines. We'll do acetylene first. I'm going to open up my acetylene. This is called bleeding or purging out the lines. We have no pressure in the system. Oxygen now as well. No pressure in the system. And then what we want to do to make sure everybody starts with the same setup is we're going to back off these adjustments here. Okay, so that they're loose. We're not going to screw it all the way out, just so that it's loose, okay? That way everybody starts with the same setup every single time. Now remember to put everything back. So if you're using different torch tips, you're going to want to put your torch tips back, etc. All right, hood down. We're going to adjust the flame. So a small turn with the acetylene. You're going to get a little bit of soot. Now we're going to turn up that acetylene until we have an inch separating from it growing to a larger flame. Like that. Now I can adjust my oxygen. When I adjust my oxygen, you can see we have 3 cones. We have an outer cone, a middle cone, and an inner cone. We want to adjust the oxygen until that middle cone disappears into that really small blue flame. This is a neutral flame. This is what we want for welding. If I keep turning it, we'll get an oxidizing flame. And if I back it off, we'll get like a carburizing flame. And then to shut this down, I'll back off my oxygen and then back off. Okay, now we're going to get into welding. So the first step in learning the basics of Oxy Acetylene welding is just learning how to carry a puddle with the torch. So this is autogenous. We're not adding any filler metal into the joint. And we're just welding in the flat position. That inner cone is about a 3/32 away from the plate. And it's important that you wait patiently until you see a molten, glowing orange puddle before you start moving. Then you can move at a consistent pace. You don't want it to get too wide. You don't want it to be too small to where you don't have a puddle at all. You can see now a little bit before I got too close, and I'll talk more about that later. So now we're actually adding filler metal into the puddle. I'm pushing that 3/32 filler metal directly into the middle of the puddle. That's very important that you push metal into the center of the puddle and not in the front, because if you push metal into the front, it will stick. Because with Oxy Acetylene, we're not working with as hot of a puddle as with TIG. So that's something, if those of you who are TIG welders and you're trying to learn Oxy Acetylene, it would be a quick fix that makes a big difference. Moving along at just a steady pace, going in a straight line. I'm not doing any circles. If I do happen to see a bubble or something, I will quickly circle the torch. So I talked earlier about if you get too close. Well, we're working with molten metal. If you get too close, you can think of it like a water in a cup. It will pop if you get too close. And before it pops, you will see the puddle change shape and get sucked in, similar to the turbulence right there. And then if you get too close or it gets too hot, that's what happens. Alright, so reading your weld, the top weld is autogenous with the flame too close to the puddle and it blows it away. The middle is just right, and the bottom weld is inconsistent in travel speed and the flame is too close to the weld puddle. These have filler metal added to them. The top is 3/32 metal, much bigger. The middle is 1/16 filler, and the bottom is feeding filler into the front of the puddle, which causes a much colder weld. Thank you.